Hi, welcome to SciBridge. Today we are going to show you a demonstration of the experiment part of our thermoelectric generator, or TEG kit. In this experiment module, students will learn how engineered materials can utilize temperature differences to produce electricity. Let's take a look at what's inside. 5 thermoelectrics, 12 thermometers, 5 screw jacks, several LEDs, 1 package of thermal grease, 5 power adapters, 5 power bricks. There are a few pieces of equipment not included in the kits but are essential for the experiment. You will need hot plates, a screwdriver, a calculator, a voltmeter, a ruler, and of course, the experiment manual for every student. For some of the items, you may need multiples to fully utilize the 5 TEG modules. Next, we are going to walk you step by step through the experiment laid out in the manual. If you haven't gone through the background part yet, please feel free to pause the video now and review the background materials. In the first portion, we will determine the Seebeck coefficient and the figure of merit using temperature and voltage values. Since the Seebeck coefficient determines the amount of potential difference we can generate from a certain temperature differential, we can apply several temperature differentials, measure the voltage output, and determine the Seebeck coefficient from their slope. Before we increase the temperature, let's attach the thermometers, one onto the surface of the hot plate and one onto the heat-sinking legs of the TE module. Use the 2 alligator clips to connect the black and red wires to a voltmeter. Set the temperature of the hot plate to 40 degrees Celsius. After the reading of the thermometers reaches approximately 40 degrees, put the thermoelectric module onto the hot plate with the heat sink facing up. Wait for the hot side temperature to stabilize and the voltage to reach its maximum. Write down the hot side and the cold side temperatures and the output voltage in the table. Then, increase the temperature to 50 degrees and record the values once the temperature stabilizes. Repeat this step until you obtain 5 sets of values. Write down the hot and cold side temperatures along with the corresponding voltages. We can plot these values on the next page. Find the best fit linear line through the 5 data points and make this line go through the origin. Find one point on the linear line that is far away from the origin and use the ruler to estimate the corresponding voltage and temperature difference values. Calculate the slope of the voltage versus temperature difference. This is the Seebeck coefficient. Next, we are going to walk you step by step through the experiment of lighting an LED using the voltage generated from the TEG. Please feel free to pause the video to refer to the manual. Before doing the experiment, we first need to figure out how to wire the circuit. Based on the specifications, a voltage of at least 2 volts is required to light a red LED. We will operate this experiment at a temperature difference of 80 degrees. To reach the 2-volt requirement, we will need multiple TEGs, or at least 3. In electrical circuitry, a series connection of voltage sources will produce a cumulative effect as opposed to a parallel connection. Hence, since we are using multiple TEGs to amplify the voltage difference, we will connect the 3 TEGs in series. Thus, the circuit diagram we need will be the following. Now, we need to set up the experiment based on this diagram. The experimental setup is similar to when we measured the Seebeck coefficient, only with an increased number of TEGs. To connect the TEGs in series, join the negative terminal of one TEG to the positive terminal of another one, and so on. Once the required number of TGs are connected, the two remaining wires, one from the positive terminal of one TG and another from the negative terminal of another TG, are the voltage outputs. The wire from the negative terminal is to be connected to the shorter leg, and the wire coming from the positive terminal is to be connected to the long leg of the LED. If the circuit is closed, but the LED doesn't light up, you may need to add additional TEGs to produce the required voltage. Once you have built enough voltage and the right circuit, the LED will light up. As discussed in the lab manual, a TEG can also be used to produce a temperature differential using an applied voltage differential. This final segment of the experimental module will demonstrate this phenomenon, providing a glimpse at the application of TEG modules as thermoelectric coolers. We will need to tape the thermocouples onto the TEG in order to establish a good thermal interface. Tape one end of the thermocouple onto the hot side and another onto the cold side. In order to power the TEG, you will need to stick both black and red wires into the screw jack. Once you insert either wire, you can tighten the connection by screwing the bolt into place with a screwdriver. Do this for both the black and red wire, and then test the connection to verify that the wire will hold in place. After you finish this step, you can plug the power strip into the screw jack and then the power brick into a wall socket. In this experiment module, we learned how to measure the voltage generated from a temperature differential and how to calculate the Seebeck coefficient. We also learned how to wire multiple TEGs to produce a net sum of voltage required to power an LED. We hope that this basic tutorial will provide you the foundation to explore your own experiments with thermoelectrics.